going to continue this related rates. I'm going to do this. I'm going to do a couple of examples. And one of the things you're going to notice is, I know you love word problems, but all of these are word problems. So we need to unpack all the different pieces that you're going to really want to know how to extract from the problem. That's going to be an important piece. So one of the things that's going to be important is, what even are you dealing with? In this case, it's a rectangle. So you should know, oh, I'm dealing with that shape. Has a length of 4 inches and a width of 9 inches. Now, one of the things to know is that's not the extent of this rectangle, because the sides are changing. So if you imagine this thing is expanding, the length is, or decreasing in this case, the length is decreasing by 6 inches per second. The width is shrinking at 2 inches per second. So this thing is just shrinking down. The question is, what is the rate of change of the perimeter? So it's a rate of change of the perimeter. So when I think about like rate of change of the perimeter, I might think of that as dp over dt, where p is the perimeter. The perimeter of a rectangle, if you think about like a rectangle, you got a length and you got a width. So the perimeter is 2 of the lengths plus 2 of the widths, right? Now, some of the information that they give you, they tell you the length is 4 inches. They tell you the width is 9 inches. I know my drawing doesn't show that, but it doesn't really matter. Now, they tell me the length is decreasing. So that's a rate of change. That's dl dt. Notice that if you think about units of measure, those are in inches. This is going to be in inches per second. Now I put a negative there because I got to signify some kind of deal with decreasing. The width is shrinking, which again is another way of describing decreasing. So that's dw dt is decreasing at 2. That's also in inches per second. So think of that as a rate of change. You know, the unit is in inches per second. That's a way of describing a rate. You know, just like your car runs in miles per hour, that describes a rate. Inches per second describes a rate as well. So from here, what we're going to do is we're going to differentiate this perimeter equation, just like we used this information up here. Similar to what we did with that area equation, we're going to differentiate this perimeter equation, but we're differentiating it with respect to time. So what we're going to do is, if we would differentiate the left side with respect to time, we would have dp over dt. If we differentiate the right side with respect to time, it would be 2 dl over dt plus 2 dw over dt, because we're differentiating with respect to this brand new variable. So in this case, well, good thing is we have everything we need. Notice that we have -6 that we can plug in for dl dt. We have -2. Oh, that's not what I want to do. Hold on. Do that. We have -2 that I can plug in for dw dt. And then we'll just have the answer. That means dp dt is equal to 2 times -6 plus 2 times -2. So that's -12 minus 4 more, or -16. And that's a rate of change. It's a rate of change for perimeter. Perimeter is measured in inches. Since it's a rate of change, we're going to put seconds. So now we're getting some context of where this differentiation could be handled. So the idea is this rectangle is shrinking. All right, so let me go on to the next one. I got 4 examples. Take one like this, and you can write the information down, but I got a rectangle, has a length of 1 inch. So again, I know it's a rectangle. Has a width of 8 inches. Sides are changing. The length is decreasing by 10, but in this case, the width is growing by 6. What is the rate of change of the area? So again, we're looking at what is the rate of change, but this time it's the area. Think about a rectangle. We have a length and we have a width. The length is equal to 1 inch. The width is equal to 8 inches. The change of the width, it's growing at 6 inches per second. So that's going to be positive. The length is decreasing by 10 inches per second. The question is, what is the rate of change of the area? The area is length times width, right? I said times. I know when I differentiate that side, I'm going to try to figure out I'm going to use the product rule. The area is changing at a rate is what we're supposed to figure out. That's dA over dt. It's not asking what the area is. It's saying how fast is the area changing. So let's go through what we would do. If we differentiate this equation, we would have dA over dt is equal to dL over dt times W plus L times dW dt. Again, I used the product rule on that. It was the product of L times W, so I'm going to differentiate using the product rule. At this point, I have everything I need to plug in. Okay, I can plug in all the pieces that I have. I know that I'm looking for dA over dt. I know dL dt is negative 10. I know W is equal to 8. I know L is equal to 1. And I know dW dt is equal to 6. So together I have negative 80 plus 6, which is negative 76. Now my question for you is, what would the unit of measure be in? So go ahead and pause this and think for a second what the unit of measure of dA over dt is. All right, if you're back, then here's what it is. Hopefully you said that must be in inches squared per second. It's area. Area is measured in inches squared. If we thought about the area of this thing, the area of this would be 8 inches squared at this particular moment because it's 8 times 1. Now this particular one, because of how fast the length is decreasing and how fast the width is increasing, the whole thing is actually shrinking in area. Okay, so hopefully that makes sense, and it's a rate of change. So let's take a look at this one. Now we got a right triangle. So you know out of the gate that we are dealing with a right triangle. That should signal to you, I am looking at a triangle that looks like this. Now, some other information. The legs are 33 and 44. So this one, we'll call this A. We'll say that's 33. Call this B. Let's say that's 44. Those are both in inches. Tells me whose sides are changing. The short leg is increasing 2 inches per second. Short leg would be this one. That would be dA dt is increasing by 2 inches per second. Says the long leg is shrinking at 2 inches per second. So dB over dt is shrinking. It's going down by 2 inches per second. And the question is asking, what is the rate of change of the hypotenuse? Well, so let's think about that. Hypotenuse would be this one over here. And the question is asking us, what is that? Now, we don't know what C is, but you should go off the top of your head. You should say, oh, the thing that relates these three quantities is a squared plus b squared equals c squared. That's the equation that we're going to use. Now, we have to figure out what c is. We can figure out what c is because we know that c squared is equal to 44 squared plus 33 squared at this instant. If we take our calculator out, I'm not going to do that off the top of my head, but if I figure out what c is in this case, I would do the square root of 44 squared plus 33 squared, and it's 55. Okay, so I know what c is at this instant. Now, in order to answer this question, I have to differentiate that equation. I have to differentiate it in regards to time. Why am I differentiating in regards to time? Because seconds is part of this unit of measure. So I know that I have to differentiate with respect to time. So 2a dA dt plus 2b dB dt is equal to 2c dc dt. I have everything I need to know. Remember, I figured out this was 55. So I know that c is equal to 55. I have all the information I need. I know that a is equal to 33. I know dA dt is 2. I know b is 44. I know dB dt is -2. And I know c is 55. And I'm trying to find out what dc dt is. Not simplifying. For an FRQ, a really good answer would be this. That's what dc dt is. Now, for multiple choice, you're actually going to have to come up with we're going to have to do the calculations. For delta math, you're going to have to come up with the calculations. I'll let you do that. But hopefully, you know that the unit of measure in this, I'll pause for a second to give you a chance to think about what the unit of measure is. dc dt, think about the unit of measure. Take a look at what we have in the diagram. Hopefully, you wrote down or you said to yourself, that must be in inches per second, and you would be right. If dB dt is in inches per second, and dA dt is in inches per second, then dc dt has to be in inches per second when we finish that one too. So the units matter in this. I don't think you have to worry about them for delta math, but it would matter in an FRQ for an AP question. Okay, last one. We'll unpack all the pieces of this one. A right triangle has legs of 6 inches and 8 inches. So again, we are dealing with a right triangle. Has a leg of 6 inches and another leg of 8 inches. The sides on this, the short leg is increasing by 5 inches per second, and the long leg is also growing by 2 inches per second. So the short one, dA dt, is going up by 5 inches per second, and the short one, dB dt, is going up by 2 inches per second. The question is asking, what is the rate of change of the area? Well, the area of this thing, the area of this triangle is 1/2. Actually, I'm going to write it out over here so you don't get confused. But the area is 1/2 the base times the height. Now that's the area. The question is asking, what is the rate of change of the area? That's what the question is asking. So we have to take that area formula and we have to differentiate it. Now, we're going to have to use the product rule. We don't have to use the product rule on the 1/2. That's just a constant that comes along throughout the problem. But we do have to use a product rule on the multiplication of A and B. So if we were going to differentiate this, what we would have is I would maybe have dA dt is equal to 1/2 d little a dt times b plus 1/2 d little a dt, oops, not that, a times db over dt. So I use the product rule. Notice that that right there is a product rule question. And all of this is a product rule. So at this point, I have all the information I need. If I just plug everything in, dA dt must equal 1/2 times 5 times 8 plus 1/2 times 6 times 2. If I calculate this, that's going to be 20 plus 6, so 26. Now the question is, what's the unit of measure? I'm pausing right now. You write down what you think the unit of measure is. You are right if you said this must be in inches squared per second. Because again, it's area. The area would be in inches squared. The time didn't change. It's still in seconds. But that's the way you would do that problem. Hopefully that makes sense. Good luck.